Good morning from Memphis. It is 2:10 a.m. on the morning of August 12th, 2022, and it's a beautiful clear morning, 79 degrees, and of course there are some beautiful bright solar system objects that I wanted to talk about, starting with Mars out to the east. I have to zoom in a little bit to get it to show up, but nevertheless it's getting brighter with each passing night as we catch up to it in its orbit. But I still have to zoom in somewhat to bring it out. It's actually visible now. For whatever reason, the camera managed to focus in on it, and I'm not zoomed in, so that's pretty cool. Anyway, that's Mars. Up here, of course, Jupiter. No need to zoom in at all to pick it up. Over here we have the full moon and Saturn just to its upper right, which was the main thing I wanted to talk about tonight. If I zoom in just to the moon's upper right, we see Saturn, plain as day. We'll talk a little bit about the two. So the moon, on average, 240,000 miles from the Earth. That's 1.4 light seconds. So light traveling at the speed of light takes 1.4 seconds to get to the moon, the speed of light being 186,000 miles per second, which is fast enough to circle the Earth 8 times in 1 second and reach the moon in 1.4 seconds. The moon is 30 Earth diameters away. The Earth's diameter is 8,000 miles, and so 30 times 8,000 is 240,000. The circumference of the Earth is just under 25,000 miles. Now, Saturn, on the other hand, is 900 million miles away on average, almost a billion miles. Light traveling from Saturn takes approximately an hour and a half to get here. So that's quite a distance. So if Saturn's 900 million, and the moon is 250,000, we'll round up and say 250,000. That's 250,000 miles away. And at its farthest point, the moon actually is 250,000 miles away, 250,000. So at its farthest, it's 250,000. So 900 times 4, 3,600 times farther away Saturn is. 3,600 times. Actually, it's a little farther than that, but if we round up a little bit, that number is roughly 3,600 times the distance from the Earth to the moon out to Saturn. Saturn has 80 known moons, 80, as does Jupiter. Saturn has one moon, which is a third larger. Our moon is 2,160 miles in diameter. Saturn's largest moon, Titan, 3,200 miles in diameter. So about a third bigger. Well, actually, almost half again. Almost half again as large. So if Titan were orbiting the Earth, it'd be quite a bit bigger. Another 1,000 miles across. So about half again as large. That would be pretty awesome, except for the tides. The tides would pose a bit of a problem because Titan's gravity, or the mass of Titan, actually, as I think about it, it's not that much greater than our moon, because our moon is almost entirely made of rock, but Titan has a large percentage of ice. Its density is actually quite a bit lower than our moon. So its surface gravity is about the same as our moon. But the temperature out at Saturn, minus 290 degrees Fahrenheit. That would be tough for us to adapt to. I don't think we're going to be venturing there anytime soon. But over at Jupiter, which is a mere 500 million miles from the sun, so on average 500 million miles from the Earth, the temperature out there is only minus 200 degrees Fahrenheit, so a little bit warmer than at Saturn. Another quick comparison about Saturn. If Saturn were at the distance of the moon, Saturn is 75,000 miles in diameter. So you divide that by 2, that's roughly 37 and a half. So 37 and a half times wider than the moon, roughly. So it would take up a lot of space in our sky. That would be awesome. And the rings are 175,000 miles across. So divide those by 2, almost 90 times the width of the moon. I mean, it would just be awesome. Of course, we'd be orbiting Saturn. Saturn would not be orbiting us. That would just be an awesome sight. So maybe someday we will get out to Saturn's moons and be able to see that. That would be just beyond awesome. But again, the temperature. Of course, by that time, we'd figure out a way to keep ourselves warm, even at minus 290 degrees Fahrenheit. But over at Jupiter, only minus 200. Of course, Jupiter has 4 moons the size of ours or larger that we could at least land on the outermost ones. The inner 2 are well within the radiation belts. I think we could deal with the cold probably a lot more effectively now than we could deal with the radiation, but maybe by the time we get out there we'll figure out a way to radiation-proof our spacesuits. But nevertheless, Jupiter's largest moon is about the size of Titan, maybe slightly larger, so half again as large as our moon. And its 2 smaller, large satellites are about the size of our moon. But their densities are a little bit lower, except for the innermost moon, which has a density similar to ours because of volcanic eruptions due to tidal flexing caused by orbiting Jupiter so closely and being pulled on by the other moons. So that moon has the highest density, Io, the innermost large moon. And Jupiter is 45 light minutes away. So again, 500 million times 4, it's 2,000 times as far away as the moon, roughly. Again, if the moon is 250,000 miles away and Jupiter is 500 million, so multiply that times 4, 2,000 times farther away, roughly. So the moon truly is like right at our doorstep compared to the planets of the solar system. And we go over here to Mars. Let's see if the camera will focus on it without me zooming in. It's hard to tell. I'll zoom in a little bit. There it is. About 2.5 magnification brings it out pretty well. Mars at its closest approach is 2 light minutes from Earth. Quite a bit closer than the 2 gas giant planets. Larger and farther out and still brighter. Mars is a lot closer, 2 light minutes at its closest approach. When it's at its farthest on the other side of the sun, It's a little bit farther, about 20 minutes away. Light minutes. Because the Earth is 93 million miles from the Sun. Mars is 141 million miles from the Sun on average. So when they're on opposite sides of the Sun, that's about 20 light minutes. But when they're on the same side as the Sun as they are now, anywhere from 2 to, let's say, between 2 and 5 minutes away, roughly. But the delay wouldn't be too unmanageable. It would be kind of similar to what email used to be. It used to take a few minutes for emails to go back and forth. Now it's pretty close to instantaneous. Of course, Mars has 2 moons, both of which are smaller than the Earth's moon. Much smaller, much closer in. The inner moon orbits the planet at only 7 hours, so actually faster than the planet rotates. So since both moons orbit from west to east, aligned with the planet's rotation, the inner moon, Phobos, actually rises in the west and sets in the east. Rotates, or orbits faster than the planet rotates. So that would be pretty cool to see. And it does that 3 times every day. So you'd see 3 moon rises and 3 moon sets every day. That would be something different. The outer moon, Deimos, orbits in roughly 60 hours. I forget the exact number, but it's quite a bit less, or longer, I'm sorry. And so combined with the planet's rotation, it would take a little bit longer. I can't do the math exactly in my head, but if the moon takes 60 hours to orbit and the planet takes 24 hours to rotate, it's going to travel a certain fraction of an orbit during each rotation. So that would still be pretty cool to see. Mars is 1/10 the mass of Earth and 1/2 its diameter. The temperatures out there are cooler than here, not as cold as on Jupiter or Saturn, but still pretty cool, down to minus 150 degrees Fahrenheit every single night. And maybe a high of 70 degrees Fahrenheit at the equator during the day. But generally much, much colder away from the equator. Now, Mars's equator and poles are very similar to ours, the way they're aligned. The Earth's axis tilted 23 degrees with respect to its orbit around the Sun. Mars is 25 degrees, so it has seasons very similar to ours. But they're almost twice as long, because Mars has a year that's almost twice as long as ours, so the seasons are almost 6 months long. And winter is just bitterly, bitterly cold. And there's also the Perseid meteor shower going on tonight, which will really start picking up here in a couple hours. I was up early today, so I'm not going to stay up in time to see the peak, so I don't think. But I might. Had to get a tune-up for my car. It had a leaky valve cover gasket, so I had to take that in and get that replaced. So I did that. I had to get up early because the car, well, mechanics are just backed up. I mean, you really have to have an appointment. I wanted to get it done, so I got that done this morning and really got quite a bit done today. We've got a gig on Saturday at the Bartlett Farmers Market, and I rehearsed most of the day for that with my fellow keyboardist, and the lead singer will be with us tomorrow to rehearse. And I thank you for watching.